Here's integrated 3. It's problem 9-128. Let's get it and read it. It says, Carmel picks an integer from 1 to 12 as a value for C in this quadratic equation here. What is the probability that his equation will have complex roots? Well, we get complex roots when we have like plus or minus I, and that happens when you try to factor something, it won't factor, then you stick it in the quadratic formula, and then you get a negative sign under here. If that's happened to you before, you know what I'm talking about. You tried to factor this, it didn't work. So you plugged all the numbers in, and then under here you get like negative 22 or something. That gives you an I. That gives you the plus or minus I, and that means you've got complex roots. So we're saying, what is the probability of getting a complex root if C is any of these numbers? And the numbers 1 to 12. So we don't know. I don't want to try every single number. You could try every single number and plug each one in one at a time into the quadratic formula, but that would take a long time. There's a better way. And so the better way is to know, just take the fact that you know that this thing has to be negative for it to be complex. Because we're trying to find the probability of a complex root, and probability is the favorable over total. There's 12 total numbers, I think. Right. And so we want to know how many of those numbers give us a complex root. And the complex root happens when this thing here is negative. So I can just take that part out and save myself the work of doing the other part. And so I'll just do a little algebra. So what I'm doing is I'm taking this and I'm going to substitute in 4 for B, because that's, remember, this thing's A, this thing's B, and this thing's C. Okay, I'm going to plug in the 4 for B, and I'm going to plug in 1 for A, and then I'm going to solve this thing. Well, I'm going to say we want it to be negative for a complex root. So what I did is I said it was less than 0, because less than 0 means negative. And then I plug in my numbers, and I'm going to actually solve it like a little algebra problem here. So I plug in my 4. I got 4 squared minus 4 times 1 times C. That gives me this line right here. And then if I subtract 16 from both sides, then I get negative 4C is less than negative 16. And you might not remember this, but if you divide both sides by a negative, because I want to divide both sides by negative 4, then I'm going to get I have to flip this inequality sign around. So then I think I divided both sides by negative 1 and flipped it, and then I divided by 4. So anyway, I get that C is less than 4. So how many of these 12 numbers I get C is greater than 4. How many of these 12 numbers are greater than 4? Well, that one's not greater than 4, but these ones are. So 1, 2, 3, 4, 5, 6, 7. There's 8 numbers that are greater than 4, which means they're going to give me a negative underneath my square root sign, which means it's going to give me a complex answer. So that's why I wrote 8 over 12. And that reduces, if I divide by 4 on the top and bottom, that reduces to 2/3, and that's the answer.